My name is Lucia De Stefano. I am associate professor at Universidad Complutense de Madrid in Spain. And in CLINT, I am responsible for a case study in Spain in the Douro river basin. So in CLINT, we will work in a sub-basin of the Douro river basin in Spain. And this is a sub-basin that is located in the northwest of Spain, where there is a lot of irrigation. It's a basin that's about 4,000 square kilometers, and 90% of the water used in that sub-basin is for irrigation. Additionally, there are environmental flows that are established for the river in order to try to reduce the impact of human uses of water on the ecosystems. So in this place, in this sub-basin, as in the rest of the Douro basin, there are recurrent droughts that affect the availability of water, both for the ecosystems and the economic activities. And the idea is that we can contribute to better manage that extreme event, this drought, since we know that with climate change, droughts are likely to increase in frequency and severity. In CLINT, we will work with drought management. In this area, there is a very intense use of water. So if we manage to adjust better how we allocate water during a specific year, we will be able to reduce impacts on irrigation and also impacts of drought on ecosystems. At present, the River Basin Authority uses indicators to make decisions about how much water to release during the irrigation year that are based only on historical data, which means they look at how much rainfall they had in the previous year and also how much water is in the reservoirs in the system, and they decide what to do in the incoming irrigation system. And also they decide, based on the meteorological conditions, they decide whether to restrict even more the environmental flows in the area. So we would like in CLINT to include in that indicator system for drought management also forecast, enhanced in artificial intelligence forecast that help to adjust those decisions so that maybe we can avoid applying restrictions to environmental flows if it is not necessary, and also so that we can help farmers to better plan their crop activities during the year. If you have a better understanding of what will happen in the incoming season in the next 3 to 6 months, you will be able to better make decisions and avoid unnecessary curtailments of environmental flows, and maybe you can avoid planting more crops than you can actually irrigate. In terms of how we can transmit this complex knowledge to users, well, in this basin they are used to work with uncertainties, to work with probability. They are managing uncertainty. So I think it's very important for CLINT to be very transparent about the level of certainty of the predictions and forecasts in general that we are going to produce, because that's the basis. Transparency is the basis for trust. The more they trust the forecast, the more likely it will be that they will be willing to use it. So we need to find ways that allows us to transmit clearly what are the limitations and the advantage and the added value of the products that we are going to generate in CLINT. In our case study, our main users are the River Basin Authority and the irrigation farmers. So they are those who will benefit the most from our enhanced drought indicator. But since we are going to address also the reduction of environmental flows, we also think that if we manage to adjust better those reductions, that will be a benefit for the society as a whole, because eventually we are all environment, and if ecosystems work better, we also will benefit as a society from that improvement.